Okay, let's talk about the branches of physics. How do we split physics up to make it relatively easier to study? All right, the major branches of physics, then the first is mechanics, which is the study of motion and moving objects. Any motion, we study it under mechanics. Then we have energy. The movement of things is caused by energy. Energy flows through systems. We have to understand how energy works to understand the physics of things. Then electricity. Electricity is fascinating because you might think it's a form of energy. We push it through wires. We have electrical devices. But in fact, electricity gets to the very nature of matter. The heart of matter itself is electrical. And after that, then we have waves. Energy moves in waves, sound waves, light waves, and all of these things get together to make the physics that we see. All of this together finally comes together in the most beautiful ways when we study modern physics. So these are the branches of physics. When we get to modern physics, we finally put it all together in a relatively cohesive argument for understanding how this all works. So let's start with mechanics. Mechanics is the study of motion. Very straight up, the study of motion. And the study of motion is broken down into two basic ideas. The first is simply, what's the mathematics of motion? Kinematics. What is the mathematics of motion? After that, we have dynamics, which is the reason for motion, and that, of course, is forces. So mechanics is broken into kinematics and dynamics. To start with kinematics, the most basic of all concepts is velocity, which is just change in displacement over time. And we'll get to what displacement is and how it differs from distance. But velocity is the change in displacement over some period of time. The next concept is acceleration, which is the change in velocity over time. It is important as can be to not confuse these two ideas. Right? Velocity is just how much time it takes you to go a particular distance, but acceleration is how your velocity is changing over a period of time. Very different ideas, and we'll show you how the mathematics works. First, let's talk about distance and displacement. If I were in a car and I were moving and I took this road from A to B, and it's a curvy, windy country road, well, the distance I traveled is the actual road path I traveled. The physics concept of this is displacement, and the displacement I underwent was simply how far is it from A to B. What is that separation between A and B? That's called displacement, just a straight line from start to finish. Right? So two big ideas here are speed is distance over time. So the speed I was going is given by this distance divided by the time it took me to get there. The velocity I was going is just given by the displacement from here to here over time. So we'll want to make sure we have these well understood. Distance is to speed as displacement is to velocity. Lovely. All right, so we want to then start with some practice problems. All right, so let's take velocity and talk about the different types of velocity. We have the instantaneous velocity. That would be given by a speedometer. We have the average velocity. Now, the average velocity is going to be taken by the displacement over time. If we want to get as close as possible to the instantaneous velocity, we have to consider the smallest possible average or velocity, which would be getting the displacement down as small as possible. If we were to talk about how long it took us to go 1 meter, that is getting awfully close to our instantaneous velocity. You can see that. So in order to talk about these things, we need to know our initial velocity And we would call this v sub I. That is our initial velocity. Our final velocity we would designate with v sub f. We need these symbols to concisely place these in mathematical formula. And the first mathematical formula we're going to play with is delta v. That's our change in velocity. Now, how would we find a change in velocity? What are we going to do with change in velocity? Well, let's see. If I was moving at 20 miles an hour, and then I was moving at 30 miles an hour, what's my change in velocity? You could probably figure out right away that that's going to be 10 miles an hour. But how did we get that? Well, we started with the final velocity and subtracted the initial velocity. So Vf minus Vi. That's going to be delta V. So we will use that. Notice we didn't need to look that up. We derived that just because we're smart. So what was my change in velocity? If I was going 20 miles an hour and it ended up at 30 miles an hour, I take 30 miles an hour, subtract my 20 miles an hour, and that would be my change in velocity. 10 miles an hour, by the way. All right, so let's do a practice problem. You ready for a practice problem? Let's do it. Luke walks 1.36 kilometers in 12 minutes. What was his average velocity? So we'll want to pick up there and do this problem. But you can see right away we have some unit issues because this is kilometers, this is minutes, and we like to put everything in meters per second. So we'll be picking up there and talking about that one next time.